guys. Today I'm going to talk about NoOps on AWS. My name is Amrith. I'm a lead architect at AWS practice in DXC. We work with a variety of AWS projects, not limited to anything. Recently we work on AWS Connect as well, so that's a call center program. This has nothing to do with today's session. Today's session is going to be about NoOps. I'm going to define that later on, but before that I'm going to tell you a story about what system failures are and how things work. So first step, what are systems? All systems fail, right? So there is no system that hasn't failed at all. So web scale companies like Amazon, Google, Facebook, Instagram, they all had their outages, right? So these are the 5 reasons, 5 causes of failures that you could say. There's no human error if you see there. The reason is human causes one of these errors most of the time, right? So these system failures are natural, and it goes with scale. So internet scale companies, like I mentioned before, and there are small, medium, enterprise level. Everybody goes through some or the other form of failure. Right, how do you typically respond to these failures? You would action on them, right? You would have your on-call engineers, you'd have your BAU teams or production support team logging in, trying to fix those issues. And how are they driven? They are basically driven they're motivated to solve the problem, bring the production back to normal, bring the website back up, bring the performance of your website at the better state than it was going through that. So that is their goal. Their goal is to fix it as soon as possible. Now, what if we could automate this? The whole idea is to automate the process of things going down, bring it back online, right? How do you do that? Is that an easy thing to do? Well, yes. You have to go through a couple of steps, and it's broadly classified into 3 steps. So first is you instrument. Instrumentation is a process of collecting data from the resources that you like. So there would be your EC2 instances, there would be your functions, your pipelines. Get the data that you're interested in. So, but don't collect a lot of data and create noise, but collect the data first. And then what you do is you identify Toil. Have you heard of this term? This term is basically when you have, it's work associated with production workloads, which is manual, which is automated, which could be automatable, which is repeatable, and has no long-term value, right? But it should be scaling linearly over time, right? It's not that you could have a script that you want to delete emails from a specific person because he sends boring emails. That's not something you would want to automate it, right? That's not the value. Here we're talking about production systems. So you must identify that particular trend that's coming up. So that's Toil, identify Toil. And finally, find a way to automate it, right? You have to find a way to automate the process. Automating AWS provides a variety of tools to automate, starting with Lambda, but you don't want to use Lambda. AWS themselves, I feel that whenever there is a feature that is lacking in an AWS service, it's like the duct tape. You solve the problem using Lambda. Anything that you do, if somebody says it cannot be solved, you would probably use Lambda. And in my opinion, if you're building a serverless application, you would probably use SAM or work through Amplify. So those are probably the right ways where you would use Lambda. Lambda could do a lot of automation, but using that may not be the better ways to handle NoOps, right? So it could be ad hoc, and it'll be very difficult to manage it when your number of accounts grow. There is step functions. Step functions are where you would coordinate multiple AWS services. That's easy to do with step functions. And finally, we have Systems Manager automation. So this is a feature in Systems Manager that you could use it to manipulate and automate administrative tasks. So things that you see when your system fails, or you probably have found out that you could automate the process and you'd find a way in which to do it. So this is where you would use Systems Manager. automation. So think of this as playbooks, well-defined playbooks that you identify after you identify the toil, right? So I'm going to pass it over to my colleague Sudev, who's going to show about how to respond to something when a disk gets full.
Thanks, Amrith. Thanks, guys. So we're looking at a use case, auto disk expansion. So one of the most common tasks which we have to perform on AWS, very common task, is extending an EBS volume. So I chose this for a demo and ease of demo purposes. So let's just move forward. So ideally, in a traditional world, when you don't have automation, what would you do when your disk runs out of space? So first step is your monitoring tool picks up that alert. The next step is you log into the AWS console. You identify the instance, manually resize the volume on Amazon console, and then log into the operating system, whether Linux or Windows, and resize the file system. So there are a lot of manual tasks here. So ideally, we would like to automate such repetitive tasks where we just want to expand the volume and avoid scenarios where the servers crash. So, yeah, let's dive into the demo. So I'll just probably quickly close this. So in this use case, or this demo, what we're going to do is we have an EC2 instance. We'll consider that this is a production EC2 instance, and it has a root volume of 10 gigs. And this instance is being monitored by a monitoring tool like Datadog for this demo purpose because it's easy to set up. So I'll just go in and just verify it's the right instance. So the instance ID ends with D92. So I can see my D92 instance is registered successfully on the test Datadog, and I can see I've also created a monitor on Datadog. So basically, monitors on Datadog is nothing but like triggers of what you want to capture, what you want to monitor. So in this case, we are monitoring the root file system of a Linux instance. So I've created a monitor for that. And I'll just verify whether the root device is also reporting successfully on the monitor. So yes, I can confirm that because I can see the instance ID is D92 here. So what I'm going to do is I'll just quickly log into this before I go there. So I'll just show you the root volume size at the moment. It's 10 gigs. So I'll just log into the instance. Is this clear? Yeah. So I'll first quickly check what the file system size is. For this, I'll use a command called df-h. So df is describe file system, and -h is a human readable format. So here I can see that my disk is 10 gigs, and it's 19% utilized. So for this demo purposes, I'm just going to try to fill up this disk by creating a dummy file. So for that, I'll use a command called fallocate. And I will specify the option -l, which specifies the length of the file. And what I'm going to do is I'm going to create an 8 gigabytes file, and I will give a file name. So I'll say demo.txt. OK, that's done. So I'll again quickly look at my disk utilization. You can see my utilization is 99%. Right now, while the automation happens behind the scenes, so I'll just quickly go back to my presentation. Yep. So behind the scenes or high level, what's happening here is we have a production EC2 instances which are being monitored by Datadog. And Datadog in turn integrates with API gateway in the account, and API gateway in turn triggers an SSM automation, and the automation in turn performs the desired activity here. So for this demo, as you know, we've used Datadog as our monitoring tool because it's easy to set up, and they give you free trials. And and the API gateway is basically triggered by Datadog using a webhook, which is set up within Datadog. That's about this slide. So a little deeper, what happens within SSM automations, right? So API gateway triggers the Datadog triggers the API gateway, and what happens within API gateway? First step of the SSM automation is you first get the Datadog trigger details, and you expand the volume on AWS layer by 10 gigs. This is done by a Lambda function. Then once that's done, we all know that once you expand a volume on EBS, you need to wait for a couple of minutes before you can resize it on the operating system. So that's what it's doing here. It just waits until the volume is all okay on AWS. The next step is automation automatically goes and checks the OS details, because you'll have different flavors of operating system like Linux, Windows, say other flavors of Linux, etc. So it branches out, it checks whether your operating system is Linux or Windows, and then it runs appropriate commands to resize the file system by 10 gigabytes. So it runs PowerShell or Linux scripts, and this is achieved using SSM run command. And finally, once all this is done, you need to get alerted. So we integrate this with our ITSM tool like ServiceNow or Freshservice or Freshdesk or whatever. So for this demo, I think we've integrated with Freshservice. So going forward, a little more deeper. So this is how an automation document steps looks like. You have several steps, and you have an action attribute, and you have a status. So the action defines what that step is doing exactly. So you can see my first step is, probably zoom in a little. So you can see my first step is AWS invoke Lambda function. Second one is wait. Third one is AWS API, branch, etc. So finally, once all this is complete, it raises a ticket with Freshservice saying it's all successful. So yeah, another cool thing I just wanted to talk about was a couple of actions in SSM document. So traditionally, when you want to run an API, say for example you want to do a describe image, you would have a Python code Lambda function which you run, and then it throws out the required output for you. But the cool thing of SSM automation is you can just achieve this by like 5 lines. So you have an action called execute AWS API. You're defining your service, which is EC2 here. Maybe I'll just zoom in a bit. Yeah. So you're defining your service, which is EC2 here, and then your API, which you want to fire, is describe image. And you're filtering out on the image name. You're filtering out with the image name, and you're exactly picking up what you need. So you're picking up that image ID just by using a selector parameter, which is super easy. If you had to do this within any other service like Lambda, etc., you need to know Python, or you need to know Node.js, etc. This makes it super easy. Another cool action here is wait for AWS resource property. Say, for example, you want to do some action on an EC2 instance once it's passed its status checks, 2 out of 2 status checks. What you would traditionally do is you would have step functions or some other service like Lambda, which keeps polling, which keeps checking, okay, it's 1 out of 2, 2 out of 2, and okay, now it's all good to go. You don't have to do that anymore. You can do that. You can achieve the same thing with AWS automations document very easily. So as you can see, we have the service, which is EC2. It's doing a describe instance status, and you're selecting the instance status using the property selector. And finally, you're checking where your desired value is running. Only when when it reaches the desired value that is running, it'll move into the next step. So that's what is happening here. I'll just quickly go back into the demo and see what's happened. Hopefully, fingers crossed, guys. So, yep, so this is my Datadog. Let me just refresh my monitor. Yep, it's slowly going. You can see the value has become 80.87, so that's 87%. We'll just wait for maybe a couple of more seconds. Come on. So. Yep. Yep, so it has gone up to 98%. You can see that in the right corner. And let's see what action has Datadog taken. So Datadog has triggered a webhook, you can see here. And you can see that it's 16 seconds ago. So yeah, so this webhook is basically the API gateway API, which it's triggered. So now let's go back into AWS console and see what our volume is now. So it was earlier 10 gigs. I'll just quickly refresh my screen. So you can see it's gone up to 20 gigs. So it's automatically resized the volume on Amazon by 10 gigabytes. I'll go into my operating system and check what's my disk size like. So you can see it's gone up, bumped up by 10 gigs, and now its utilization is just 50%. So this way we can avoid servers from crashing, and I think this is a cool way we can automate our operations.
Thanks, guys. Thanks, Sudev. So that's how you could, that's one of the stepping stone that you could think about, how you could automate it. And this is a live example. So automation in the old world was, this is how you would have a team of production support engineers working 24/7 or on call and trying to fix these issues. But today with NoOps on AWS, you'd basically do this with SSM documents, and you'd create a fleet of documents which would be your playbooks and deploy it on a fleet of accounts. You could probably have one set off in one centralized account and deploy it on multiple accounts. So each of them, you could tune them according to your standards. So today we always hire more of automators who could script rather than picking up incidents and closing them, because that's not reasonable in 2020, right? So different use cases, some of the use cases that you could see are here. So the way in which you automate, if you have a fire, you wouldn't call your firefighters. You should have your automatic sprinkler system installed, right? And the next is, there are many other use cases. My favorite use case is where you could figure out who restarted the machine, what system did that. Is my CPU being throttled? Is my CPU usage high because of a rogue process? I would want to kill it or restart it. So those are the stuff. And the example, the image that you see there, that's an automatic baby cradle. It's like if a baby cries, the cradle moves to put the baby back to sleep. When they could do that on babies, can't we do that on our systems, which is definitely possible, right? But the issue with automation is you don't want to automate everything. It's so hard because you would have to account cost and billing, right? Somebody is paying for this, for the 10 gig that was added in the past few minutes, right? So don't automate the stuff that can be fixed permanently. Here in this demo, you saw a human increasing the size of the file system. You should try to prevent that in the first place. But should something happen, you'd have this automated process to fix it, right? Then instrumentation, you should collect information, but it is okay not to collect a lot of information. Do not send it all to your incident management to make incident. It's pointless, and it's okay not to do unit tests. So as you mature with your development process, you should mature with your operations. It is key. This is one of the other philosophies. You might say, NoOps, is that a real thing? In my opinion, it is. It falls under run. So build is mostly of DevOps and GitOps. And when you run, you use NoOps methodologies. This is a stepping stone. Chaos engineering, I just want to introduce you to this term if you're not familiar with this. It has nothing to do with chaos. It is more to test your reliability of your systems. Do you want to check whether you have things available in multi-AZ? Have you really tested it? Have you really shut down those machines? Have you done that? To reach that stage, you need to go one level down. That would be NoOps. You would have to do that, right? So, you might think that, are you doing this option? You must do this because these are your stepping stones for operational excellence, which is part of your well-architected framework, if you're familiar with that. You should be able to reproduce incidents. You had an incident a couple of weeks ago. Are you sure you could fix that problem? Are you sure you have the proper operations team to tackle that issue when you get that issue again? You must apply site reliability engineering practices, right? So do you have those within your operations team? No? Read the book available online and apply those principles. And finally, at that stage is when you would apply some chaos engineering practices. It could be on anything. It could be on your serverless functions. It could be on traditional EC2 machines, right? With that, that's probably the end of this. Have you got any questions for me? Oh, Sudev.
Any questions? Anybody?
In terms of the traditional tracking of issues, especially with sort of senior stakeholders, that changes because it's no longer you get a ticket, you assign it to someone and they fix it. Now these things are sort of going on by themselves. So how's that sort of reporting change in terms of what your managers are looking at in terms of getting those metrics and issues?
So if you had seen that slide that Sudev showed, at one point, at final stage, it would send a ticket to ServiceNow. The reason we want to send a ticket to ServiceNow is to let people know that I shouldn't say ServiceNow, ITSM tool. So in that ITSM tool, it's where people would come to know that, yes, a disk was expanded, and prior to this, you should have some quotas assigned to it. This is called a cost quota. You would probably assign it to it, saying that, yes, for these set of servers, the owner should approve these many expansions. But remember that you should address the root cause of it. If you're doing this on a periodic basis, you probably have some other issue which has to be addressed. But that model, the cost ops model, should also be applied.
Is there a risk you sort of losing the incentive to look at the root cause? Because things just sort of repeat themselves and die and recover, whereas if there's no real cost implication, then the incentive of actually fixing it.
Absolutely. Remember, step 2 is to identify toil. Is this really toil? That's the question we should ask. Whether before you quantify that this server qualifies for its disk to be expanded, then you must automate it. But remember, this example involves cost, right? This example involves cost.
Yeah.
Think about the example wherein you're trying to kill a process because your system is down and it's eating up your CPU resources. That has no cost involved. You probably need to do it ASAP, right? So that doesn't involve any cost. You have most of the other use cases would not involve cost if you're trying to fix things, right? Yeah.
And just to add to that, you have an option to have an approval in the automation document. So that means to say if it's some critical automation you're trying to achieve, so you have an approval where only once the automation will stop at that stage, at the approval stage, and as soon as you say, okay, yes, approved, it moves ahead with the next steps. So you can have one level of control if you like.
And it could be integrated with a tool like OpsGenie or PagerDuty if you're using it. Imagine this situation happens and your situation is very valid, saying that a request comes in and you are the financial approver of this. It won't go to the on-call engineer. How happy would I be, right? It would go to the manager who's approving it. Let him approve it at midnight. Yeah, give that load to him. It will be his responsibility. And that is technically possible. We could have shown that, but yeah, that's there.
Any more questions?
Any more challenges? Yeah.
Is there any document automation with which you have integrated the SSM with the ServiceNow? Any?
Yep, we have integrated with ServiceNow and Freshservice of ITSM tools. Yep, we do have SSM documents created for that. So it'll be basically one step in the SSM document, which will in turn trigger a Lambda function, and the Lambda function is actually calling the API, because you cannot do a native third-party API within SSM document.
Okay, so the Lambda is actually calling the ServiceNow.
Yes,
creating the tickets.
Correct.
ServiceNow tickets.
Yes, it raises appropriate ServiceNow tickets. It raises change tickets or incident tickets. You can call different APIs in Lambda, right? So the slide which I spoke about is about AWS. It was specific to AWS APIs where you don't need Lambda. You can achieve it within SSM automation document. But if you need to call a third-party API, SSM document doesn't support it, so you still need to go with Lambda.
Any more questions? No, thank you very much, guys.
Thank you.